Hi, my name's Andy Banta. I'm here at the Bring on the Future vBrownbag Theater, actually the vBrownbag Theater in the Bring on the Future booth at NetApp Insight. Thank you all for showing up today. My name's Andy Banta. I was just going to cover a little bit about iSCSI. So how many people know when the first fiber channel array was created or was shipped?
1995.
Close, it was 1994. Yeah, fiber channel. Yeah, so this was actually fiber channel isn't nearly as old as an awful lot of people think it was. It's just barely over 20 years old at this point. I actually worked on the host adapter that went with this fiber channel array at Sun Microsystems when this was shipped. Fiber channel was originally started out as just a point-to-point protocol, like all the other storage protocols that existed at that point, and then after it had been around for a little while, they actually decided that, hey, maybe we should network it. So very early on, this was one of the first network switches. This is actually a 0.5 gigabit fiber channel switch from Brocade. It currently is used to hold up my Mac and nothing else. Fiber channel rolled along, and I worked on a bunch of the network concepts that were associated with fiber channel, the fabric that Brocade was pushing so hard. And one of the problems was that the fiber channel people refused to actually learn anything from the TCP/IP world about how networking worked. They were very hung up on trying to make everything look like it was you had a solid bus from one end to the other, and just didn't get networking at all. When I left Sun, I actually went to VMware, and I kind of figured that I'd continue working on fiber channel stuff when I was at VMware. And after I'd been at VMware for about a week, my boss at the time walked into my office and handed me this card, a QLogic 4010 card. He said, "You ever done anything with iSCSI?" I said, "No, I hadn't." And said, "Well, we got this board from QLogic. You think you can make it work with VMware?" I said, "Yeah, probably." And he said, "Alrighty then," and walked out of my office. And so that's how I got started with iSCSI. That's just to give you a little bit of history. I was the iSCSI tech lead at VMware for most of my 8 years there, and I worked on iSCSI for about the entire time I was there, so I have a little bit idea of what I'm talking about. Here is actually a slide from VMworld 2005 when I was there talking about iSCSI then, and it was why is iSCSI interesting? Well, at that point it was 1% of the SAN market, and they were seeing fairly decent growth. That you can see this was Q1 of 2005. An awful lot of the reasons why people were interested in iSCSI at that point were the costs were a lot lower than fiber channel. Just by contrast, when I actually left VMware in 2013, about half of the storage connected up to VMware was done through iSCSI. So over the course of 8 years, it had gone from 1% of the VMware Connect up to about 50% of the VMware Connect. So iSCSI actually did really take off. This is actually a slide from one of my presentations that I did at a VMware conference. So this was kind of showing how iSCSI and VMware grew up together. Let me cover a little bit about why iSCSI is really interesting and why people are paying attention to it. The biggest reason is it's a commodity transport. The idea is that the iSCSI standard was put together in 2001, 2002, 2003, and it really hasn't changed a whole lot since then. The whole idea is that iSCSI defines how you encapsulate SCSI commands and transport them over a TCP/IP network. This means that instead of actually having to define how the wires work, how the signaling works, how you make sure that your data gets from one place to another in order, you actually just take advantage of networking stuff that already exists. TCP/IP takes care of all of this stuff for you already. So the only thing that iSCSI really needs to define is how you encapsulate a SCSI command to throw it over a TCP/IP connection. The advantages of this are that every time Ethernet speeds go up, your iSCSI speeds go up. So iSCSI piggybacks on all of the technology changes that happen with Ethernet every day. We've gone from 10 megabit to 100 gigabit seamlessly, and iSCSI still just works the way it always had. iSCSI provides an awful lot of the same ideas that fiber channel has in their zoning with fiber channel switches. You can do VLANs in your switches if you want. The advantages are that with iSCSI, you can also do things like long distance routing, and it still just works. All of the technology that has come along to enhance Ethernet over the years, the idea of offloading things to cards, so the long read offloads, the TCP segment offloads, the complete TCPI offload engines that are available in Ethernet cards, now just seamlessly take advantage of iSCSI as well. One of the best things is that TCP/IP has not stood still either. Other people have been enhancing TCP/IP for all sorts of other reasons, adding things like encryption, adding things like better routing protocols. It provided a way to guarantee transport from one end to the other day one. You didn't need to come up with any other way of doing that. Just a little bit of an explanation of what iSCSI actually is. It's the idea that you can actually take SCSI commands, which are reads, writes, that type of stuff, in between a host and a disk, and encapsulate it into TCP/IP protocol packet. It can run on just about any physical network that actually uses TCP/IP. That's typically Ethernet in most environments, but InfiniBand. There's been people who've come up with all sorts of other other networks that you can run TCP/IP over. SCSI actually defines ways to allow just about any device to be attached from one end to another. Typically, we think about it being compute equipment on one side and storage equipment on the other. At the same time, there's SCSI protocols for doing things like printing and scanning, and there's even like SCSI mouse protocols. So you can do all sorts of stuff. iSCSI was actually defined in, I think the RFC was accepted in 2003 in RFC 3720. So this is the Internet Engineering Task Force, IETF.org. You can go find all of these standards here, freely published, easy to read. They actually updated it, I think 2012, 2013, because there had been a handful of add-on things to iSCSI that had come along, and they just rolled that all into one standard. But the basis for what was around was still 3720, and that still is the basis for what iSCSI is today, even though they've rolled it into other things. Just a quick view of what iSCSI is. So you have on the server side, you would have your typical network stack, and that's connected up to the network. And on the storage side, you again have your network stack there. So iSCSI is actually going to be the communication between the iSCSI initiator layer and the iSCSI target layer that sit on top of your both network and physical layers, but above your SCSI storage stack and whatever applications might be running. This is the big messy picture to show you all the cool things that you can potentially do with iSCSI. I'm not going to go into this in a huge amount of detail. The whole idea here is that the purple pieces are the sessions that would exist between, like your, in this case, an ESX host and an array. The yellow things would be the connections through those sessions, so you can potentially have multiple connections through a session. It's if you want to get into all sorts of the hairy bits of iSCSI, I'd be happy to talk to you about it for days. I don't have days to talk about it here. A couple of cool things that iSCSI did bring to the table were the idea that you could go discover iSCSI targets on the fly. So all you need to do was they had the static discovery, which is an awful lot like the way Fiber Channel does it as well, where you actually need to come up with the name of your storage, provide it to the host, and tell it here's exactly where your storage is. iSCSI also had the idea that there's dynamic discovery. So all you need to do is tell your host what the address of your storage is, and the storage is going to report back all of the targets that it has available and what IP addresses that are available on. This is really cool, and this ties in nicely with iSCSI login redirection, another idea where you actually, iSCSI can issue a login to a storage system. The storage system can say, oh no, the target you want actually temporarily moved to some other place, and the host will relog in there. These two pieces combined are actually what makes scale-out storage really work. There is no way to actually do scale-out storage with Fiber Channel. There's no way to go dynamically find additional new nodes, have them automatically show up, be able to have workloads move from one node to another, move from one location to another, and have it seamlessly work. The combination of dynamic discovery and iSCSI login redirection are what made EqualLogic and Left Hand available to work as scale-out storage initially, first-generation storage, scale-out storage vendors, and it's definitely what allows SolidFire to work as scale-out storage as well. SolidFire has a fiber channel offering. At the end of the day, it's not really scale-out either. You end up putting a couple fiber channel gateways in front of your storage, and the storage behind the fiber channel gateways scales out, so you don't actually end up with the linear capacity and performance scale out that you get with SolidFire in an iSCSI environment. iSCSI login actually works with another piece called an async logout from a target. So if the target side actually wants an iSCSI session to go to another port, it can actually send a logout to the iSCSI host and tell it, hey, I want you to connect up to another port. This actually is the way that just about every scale-out storage system does load balancing. It's if there's a load on one node, then it wants the load moved to another node, it's going to send a logout to the host and tell it to go somewhere else. The same thing can happen if you just drop the session. This could happen if you have a controller or a node that goes down. In that case, the host would attempt to immediately relog into whatever target it was, and in that case, it might actually be redirected to some other node. It's a way of dealing with self-healing. That was what I was just explaining. And it also allows you to do upgrades with absolutely no disruption. That's another feature that just about every scale-out storage system has had that an awful lot of other storage systems haven't. If you have a bunch of different nodes and you want to upgrade one, you just redirect all the traffic that had been going to that node to a different one while you upgrade it. Once it's back up and running, you can bring loads back onto that node. And this can all happen without the user ever seeing anything happening. iSCSI has a handful of security pieces built in. Another thing that Fibre Channel has fought with over the years. So there's authentication end-to-end just to make sure that the targets and the hosts know who the other one is. There's in-flight encryption, just to make sure that nobody can actually snoop the data while it's going on. And actually, an awful lot of people, including VMware, recommend that you actually run iSCSI on separate networks from where you run typical network traffic. This makes sure that other network traffic isn't actually going to get in the way of your iSCSI traffic, and it also provides the security to make sure that nobody is going to be able to, browse the web and snoop the iSCSI traffic at the same time. Software-defined iSCSI is probably the final benefit of actually things being a commodity transport. So the whole idea is that I showed you the HBA that I had worked on when I first started VMware. By the time I had been at VMware for about 4 years, we decided we don't need iSCSI HBAs anymore. We're just going to write an iSCSI stack in software. It's going to use the normal Ethernet ports that come on your host. There was absolutely no need for you to go out and buy additional hardware, expensive hardware at that, to be able to run iSCSI. When it came right down to it, the cost of a CPU core was cheaper than the cost of an HBA. If you needed to actually buy more CPU cores to be able to run iSCSI the way you wanted to, it was cheaper to buy more CPU cores than go out and buy HBAs. The scalability came along with when we went to the severe high core count processors. So probably 2005 or so, the idea that you might see 2 cores in a processor was common. Today, you typically see anywhere from 6 to 12 to 16 cores in a processor, and you end up eating core. And just to keep this in perspective, when I had left VMware, saturating a 10 gigabit Ethernet link for iSCSI took about 1.7 cores. Another concept here is that it actually allows you to run iSCSI in virtual machines. So when you have software initiators in your VMs, you can actually run iSCSI, an iSCSI initiator in your VM. Microsoft, Linux, just about everybody else has an iSCSI initiator. VMware has an iSCSI initiator, and you can actually run those systems as virtual machines, which means that they can use their virtual network connections to run iSCSI. They don't actually need to do anything physical. You can't do that with Fiber Channel. There's no way to actually virtualize a Fiber Channel. Well, there is, but there are not too many people have actually done virtual Fiber Channel adapters. And as I mentioned, it's supported by every major host OS. Another cool thing about iSCSI, another reason that SolidFire looked at it so closely, is how easy it is to automate it. There isn't a whole lot of configuration that you need to do. You don't need to build spreadsheets of worldwide names to match from host to target. And from the VMware and the SolidFire perspective, it's entirely, you can configure it entirely through APIs. Absolutely no need to sit there and configure all this stuff by hand. Especially with scale-out systems, this is very simple. As you add more nodes, both compute nodes and storage nodes, you typically don't need to actually change a whole lot of the automation that you're using to do the discovery and hooking up new targets. I'll cover just a couple of things that have come along lately, new stuff that's available for iSCSI. There have been a bunch of protocol consolidations that I've mentioned. They got rid of a couple things that were written into the original standard that nobody implemented, wise move. And they actually added a couple additional things into the protocol that took advantage of a couple of the shortcomings on just how if commands went awry, how you got rid of them more quickly. There's been very little changes. One of the big things that is coming along is the idea that you actually can use iSCSI to do remote DMA between host and target. So the idea that you can actually map memory in your host to a storage system rather than having to do read and write commands between this. So just a quick review of what DMA was. DMA took the idea that you can actually have devices that can directly address memory in your host system, as opposed to actually having the CPU need to do the transition, reading the stuff from the device and then putting it in memory for you. Remote DMA is the exact same concept, except that you get the CPU out of the way with a remote device that actually knows how to address memory within your host system. It eliminates a copy that you end up with just about any time that you would need to do a network transition now. Typically with typical read and write commands with the network, when you ask for a read from storage, the data is going to come in at some point. The network stack is going to get that and say, okay, I have this data, I need to put it somewhere. It finds someplace to put it, and then it says, oh, okay, this is actually read data for this command that was over here. I need to copy it into where it belonged. RDMA actually gets rid of this, and at the 10 gigabit to 25 gigabit transition is where you actually start seeing this copy chew up an awful lot of CPU resources. So I mentioned the 1.7 cores at 10 gigabits. When you start ending up with probably roughly 2.5 times that much, it's probably not going to be exactly 2.5 times that much because there's a little bit of protocol stuff, but an awful lot of the time that's spent with the CPU is actually doing that copy. Getting rid of that copy is important. iSCSI is actually an open standard, entirely like iSCSI, entirely out there with IETF and IEEE. Actually, it is IETF again. There's a handful of different methods that have been put together for defining how iSCSI is used to do RDMA. There's one that actually uses TCP/IP. This again would be similar to the way iSCSI works. It is going to take advantage of TCP/IP as it goes forward. There's another one named Rocky that actually attempts to define new protocols over Ethernet that do the same type of thing. My personal opinion on that is that if you're going to try to redefine the resiliency, the ordering, making sure the data actually gets from one end to the other, you're probably fighting an uphill battle against TCP/IP again. It gets rid of the idea of traditional reads or writes, and instead it actually sets up address ranges for you to copy and read into. A typical ISR read command example, it would be that there's a SCSI read command sent, and it actually sends control to the reverse side, to the target side. The target side is then going to do writes directly into host memory at the locations where the read request was put in until it's actually done, and it will send a SCSI response at that point. So it'll still be a multi-segment transition that goes across the wire, but when it gets back to the host side, there won't actually be the copying of it into a buffer and then finding where the read request came from. Write is very similar. A little bit. One thing that's a little bit different there is that ISR actually continued to take advantage of the idea that you can send a bunch of data with the initial SCSI write command. So when you send the SCSI write command with iSCSI, you're actually allowed to bundle the first chunk of data associated with that write command into the command itself. After that has been written, you can see that it's the same idea of the target side is actually going to read from the host memory to get the rest of the data and then send the response as well. This is actually just some SNIA research on the type of CPU that's used. So on this side, on the green side, we can see the amount of CPU used for doing a bunch of 128K writes is quite a bit less. So ISR actually is one of the things that's coming along, probably something that if you're interested in iSCSI, you need to pay attention to as well. And that's what I had to cover on iSCSI today. Let me know if you have any questions, any comments. Yeah.
So with NVMe coming around, is SolidFire doing anything to integrate that and get rid of the SCSI layer, or full steam ahead iSCSI?
Yes, there's going to be things going on with NVMe. I can't talk about specific roadmaps. What I can tell you is that SolidFire is going to continue to stick with the entire idea that it's software-defined storage, that it's that everything that it does is going to happen on commodity hardware. So the changes you're going to see with SolidFire are going to be that when there are platforms that actually have NVMe available, SolidFire's Element OS will take advantage of that. I'm quite certain that we will continue to use completely off-the-shelf commodity hardware to make it happen. We're not going to go out and design new special widgets ourselves. I don't think that NVMe has solved the scale-out problem either. And so I think what you're going to see is that NVMe is going to be the in-box interconnect for SolidFire, and I think we're looking more at 25 and 50 gigabit Ethernet for the iSCSI side rather than the 40/100 chain. I just think that's because the 25 and 50 gigabit Ethernet are a little bit more mature at this point, and they appear to be a little bit closer to becoming products. But it's just an awful lot of the way that the scale-out portions and load balancing portions of SolidFire works. I don't see us getting away from iSCSI anytime soon as the host storage interconnect. Anything else? Thanks for showing up.